Hello, calculus scholars. I hope everybody has had a productive e-learning week. So we are going to today do the second fundamental theorem of calculus, which is that 4.5 lesson. And you're free to watch that YouTube video that we had in class. But I also wanted to kind of do a video where I kind of worked out a few examples live in the process as well to support you. And we will make the IP just that 4.5 worksheet that I assigned on that day that the sub was there. And now you'll be able to turn it in, take the screenshot of it, and everybody will kind of be at the same place as we begin, 4.6 next week, which is the integration by U substitution. All right, so anyways, today we are going to be talking about the fundamental theorem of calculus 2. Now, one thing to kind of note here is that the most common notation is this capital F symbol. So capital F means antiderivative. And what we kind of want to see, so what they say is if, capital F of x equals the integral from, usually there's going to be like a number, some type of constant on a lower limit, and then some type of function that we'll just call g of x. So g of x could be as simple as x, or it could be, something a little bit more complicated, like x squared or square root of x. So it's, some type of function as the upper limit of integration of, and we'll usually have something that's kind of in terms of t. What this is saying is that when we take the derivative of this antiderivative, so let's have that sink in there for a minute. Taking the derivative of the antiderivative, is equal to f of g of x. So we're literally, just plugging in the upper limit of integration and multiply by the derivative of the upper limit of integration. Then what we need to do, if we look at an example, like antiderivative of f of x, let's say that we have, in this problem, the integral from -4 to x. So this is kind of like our simple version of a fundamental theorem of calculus 2 problem. So on the easy versions, like this first one, all what you really have to do, and I'll just, kind of write the answer here. The answer is just x minus 1. Let that sink in there for a minute. So all what we did is we replaced t with x. And what this has told us basically is that when we take the derivative of the antiderivative, it is as if we didn't have the integral symbol at all. Now, if we're kind of staying true to the formula, and this can help us for some of the harder problems, maybe I call g of x, just call that x, and g prime of x is equal to 1. So if I'm kind of, staying true, f of g of x, what this is telling us is it's just telling us to plug in x and then multiply by the derivative, and we would still get that x minus 1. All right, let's go to a more interesting example that's maybe kind of at the next level. So here, I have an upper limit of integration that is something a little bit different than just x. So we'll say that that's x squared. And the derivative of this is 2x. So if I'm kind of writing the formula of f of g of x times g prime of x, well, f of g of x, so what this is telling us to do is it's telling us to plug in x squared. So what we did here is instead of writing, 2t, negative 2t plus 2, we put in an x squared for t. Just like evaluating a composition of function in like an algebra 2 class. And then we could just multiply this by that g prime of x. And fortunately, we already kind of did our scratch work of g prime of x. So I would just multiply that by 2x. Now this is the correct application of a fundamental theorem of calculus 2, just what we did here. I think we can clean this up a little bit. So let's see, 2 times negative 2 is negative 4. X squared times x is x cubed. And then 2 times 2x is 4x. Final answer. All right, the last one here. What I would do for this one, I would first look at the upper limit of integration. So I'm going to circle that. So I'm going to say that g of x is x cubed. And then g prime of x is 3x squared. And I'm going to use that formula again. It says that I'm going to do f of g of x times g prime of x. Now, f of g of x, which tells us that when we see t, we plug in x cubed. So this would be 1 over x cubed. Hold on a second here. Write that 3 just a little clearer. cubed. So we put in an x cubed for t, and we have to cube that again. And then we just multiply by 3x squared. So that's equal to 3x squared over x to the 9th. And I'm fine, if you just write your answer like that. That shows me that you did the calculus theorem correctly. But if we want to use a little property of exponents to simplify, x to the 2 over x to the 9, that's like x to the negative 7th. So that just simplifies into 3 over x to the 7th. So just to recall here, f of g of x. This tells us to plug in your upper limit. So if it's a simple example, like the first one, where your upper limit is just x, you put in x for t. If we're going to a more difficult example, something that has like x squared or x cubed, well, in the second example, you put in x squared for t. On the third example, you put in x cubed for t. And you evaluate it like a composition of functions that you did in Algebra 2 class. And I always like circling that upper limit of integration. I call that the g of x. And then I take the derivative of that. So that way I can just go right to the formula of that second fundamental theorem of calculus. And I'll just box this in here. And this is something that you can use consistently on the practice. I wish everybody a good weekend, and congratulations for finishing your first week of e-learning.